Okay, so we're going to be talking about this thing called enthalpy, and you guys don't need to write down everything here, but I'm just going to tell you guys what's important. I want you guys to write down somewhere that enthalpy, okay, is symbolized by this symbol right here. There's going to be a triangle. This means delta or change, and then we're going to write H. Okay, so this is the symbol for enthalpy, delta H. And enthalpy or delta H basically tells you the amount of energy that is either released or absorbed in a reaction. Okay? So it's the amount of energy that's absorbed or released in a chemical reaction. All right, so whenever we have a number for anything, so enthalpy is given to you in the terms of a number. So let's say, for example, it's like 500, okay? But we can't have a number by itself. We always have to have a unit of measurement for it, okay? Enthalpy is either measured in joules, so you guys can write somewhere that it's measured in J, or it's measured in kilojoules, which is kJ. And these are just ways that we measure energy. Okay, so whenever I ask you to find the enthalpy of a reaction or how much energy is absorbed or released, you're going to give me a number, but you are also going to give me the unit of measurement. So joules or kilojoules is what we're going to be working with. Okay, so just keep an eye out for that. Again, for all the numbers in our class, we have to have a label for it. And the label is going to be joules or kilojoules. All right, so when it comes to the delta H or the enthalpy, and I want you guys to write this down, if it is an exothermic reaction, that means your delta H is going to be a negative number. Okay, so if you have a negative delta H, you're going to have an exothermic reaction. And if you have an endothermic reaction, the delta H is going to be a positive number. Okay, so just keep that in mind. You're usually going to be given the number for delta H. So when you have a chemical equation, it's going to say delta H equals positive or negative number. By looking at whether it's negative or positive, it's going to tell you if it's exothermic or endothermic, whether the system is releasing or absorbing energy. Okay, so this is the only example we're going to do. This kind of combines the enthalpy, the exo-endo stuff with stoichiometry, which we've been working on the whole year. But basically, it's telling you that if 0.22 grams of H2 reacts with oxygen, how much energy will be absorbed or released? So let's start with that first question. How much energy or will energy be absorbed or released? Okay, in order to solve this, we need to look at the delta H right here. And this is a new thing that's given to us with our chemical equations. If you guys take a look at the delta H value, is this positive or negative? Okay, it's negative, right? So if this is a negative delta H value, that means that energy is being released. Okay, so just keep that in mind. You guys can jot this down for the answer to part A, because this is what you're going to be doing on your assignment. If delta H is negative, it means that energy is being released, which means that this is going to be an exothermic reaction. Okay, and that's all you really need to do for that first part. Okay, just figure out if it is exothermic or endothermic by looking at the delta H. Just need to look at if it's positive or negative. Okay. Any questions on that one? Part's pretty easy. All right, now this is where the stoichiometry comes into play. The question is asking how much energy is going to be absorbed or released. So in this question, what we are trying to find out is basically how much energy is produced. That means our final answer has to be in terms of whatever energy value is given to us. The question says the enthalpy is negative 570 kilojoules. So our final answer has to be a number, but it also has to have the term kilojoules behind it. Okay, so we're looking for kilojoules here. All right, now in order to solve this, it's just like almost like just regular stoichiometry. The first step that you want to take is you want to balance your chemical equation. Okay, so we want to balance this equation. So here, if you feel comfortable balancing on your own, you can go ahead and just kind of ignore me for a bit. Try balancing, but I know it's been a while since we did this, so I'll go over it step by step. Okay. All right, so for balancing, we first need to identify what elements are inside of our equation. So we look for the capital letters. So if we look at the equation, we got capital H, so we have hydrogen. We have capital O, which is oxygen. And it looks like those are the only two elements that we have. So what we're going to do is we're going to make a table, and we're going to count how many hydrogens, how many oxygens we have on the left side versus the right side. Okay, so take about 30 seconds. I want you guys to try filling in the table after you draw it. Count how many hydrogens and oxygens are on the left and the right side. Alright guys, so for the counts, if you guys take a look on the left side, there are 2 hydrogens, 2 oxygens, and on the right side, there are 2 hydrogens and 1 oxygen. Okay. Alright, now if we take a look, the one that's not balanced is going to be the oxygen. So we need to add oxygen to the right side. Okay, unfortunately, we can't just add O by itself. We have to add the entire molecule. So let's add an entire H2O molecule. And if we do that, we're going to change all the numbers on the right side. So add the H2O and then see if you guys can adjust the numbers on the right side. I'll give you about 30 seconds to do that, and then we'll verify if you guys got it. So recount how many are on the right side if you add another H2O. Alright, so if you guys take a look at the right side now, there are 4 hydrogens because we had 2 and then we added 2 more. So now we have 4. And now we have 2 oxygens because we had 1 and we added another one. So we got 2. So if we take a look at our table, now the oxygens are balanced, but hydrogen is not. So we got to add hydrogen to the left side. Lucky for us, we can add H2. And if you add H2, 2 plus 2 gets us to 4. And so both hydrogen and oxygen are balanced. And so the numbers we put in the blanks are 2, 1, 2. Okay, so that's going to be the balancing portion. Alright, any questions on the balancing? That one's pretty easy. Some of the ones on your assignment are a little bit trickier than that, but they won't be too difficult. And the second step is to do the actual math. So what we're going to do is first, we're going to look at our problem and we're going to identify our starting number. If you guys take a look, our starting number is 0.22 grams of H2. So what we're going to do is we're going to start our problem with this number right here. So we're going to write 0.22 grams of H2. And it's a bit of a shorter stoic problem. There's only going to be 2 fractions, so we're going to set up 2 fractions. Alright, so let's label our fractions now. So the bottom of the first fraction is going to be what we start with, so grams of H2. So we're going to put grams of H2 here. And then the top is going to be moles of our starting chemical, which is moles of H2. Okay, and we're going to get the numbers for this from the molar mass. And for the second fraction, the bottom will be pretty much what's here, moles of H2. And the top is what we're looking for, which is kilojoules. And we're going to get these numbers from the balanced equation. Okay, so I'll give you guys a second to copy that down. If you feel comfortable finding the molar mass and plugging in, go ahead and do so, but no pressure to do that. Just copy this down, and I'll show you guys how to fill in the numbers for the fractions. So our first fraction is molar mass. So we're going to go to our periodic table, and we're going to find H2. So if we take a look at hydrogen, it's going to be on the top left. Hydrogen is 1.01, and there are 2 of them, so that's 2.02, right? And if you guys remember from molar mass, we always put the number that we add up next to grams. So we're going to put 2.02 on the bottom of the first fraction. And molar mass is the mass of 1 mole, so we just put a 1 on the top. And just to let you guys know, this position right here will always be 1. So that's the first fraction. Okay, second fraction is pretty easy since we already balanced. We're going to look for H2 on the second fraction. The number in front of H2 is 2, so we put a 2 on the bottom next to H2. And we're looking for energy or kilojoules. And if you guys take a look right here, it kind of gives you the delta H already. It's negative 570. So we're just going to put negative 570 on the top of the fraction. And that's pretty much it. You just need to plug that into your calculator and solve it out. So see if you guys can do that. I know it's been a while since we did the calc, so it's a little practice wouldn't hurt. Just remember, numbers on the top you multiply, and all the numbers on the bottom you are going to divide. So see if you guys can plug that in. Alrighty guys, so for your final answer, you should have got about negative 31, and then you're going to label your number kilojoules. Okay? So the way that you plug this in your calculator is going to be 0.22 divided by 2.02 times negative 570 divided by 2, and that's going to give us our answer right here. So what this is telling us is that 31.04 kilojoules are being released. Okay, that negative sign means that energy is going out. Okay, so that's how much energy is leaving the system when you run this chemical reaction.